Hi everyone, in this section we're going to be looking at derivatives of trig functions. So the book does a nice job going through how to do the derivative of sine and get cosine out, using the limit definition, showing you graphs of both of them so that you can do what we've talked about with derivatives and functions and antiderivatives and looking at the graph to see kind of what's happening with something else. So you can do that and go through, and that's good, it's worthwhile to do. But in this video, we're going to be talking about two things. The first thing is how you could go through from just knowing these first two that I've left unboxed here, how you could go from knowing these two to finding the rest of these, right? Just developing the rest of these from these two and, some thinking about the trig functions and our other rules. And then we're just going to do some examples where we see combinations of them, maybe some product rule, some quotient rule, just practicing integrating the trig functions as part of our toolbox of functions we're going to use. So the first thing I just want to mention, just to get you thinking, like this is a very valuable thing to be able to do, is what's the derivative of tan? So okay, tangent. What's tangent? So for this first one, we'll call this number one. For this first one, let me give myself a little more space here. To do this derivative, we have to remember that tan is sine over cosine. So this is a very valuable thing to be able to do. To be able to recognize that, actually, these trig functions, they are new functions, right? They're different functions. But really, they're just combinations of these kind of base functions, sine and cosine. So to do the derivative of tan, I'm really doing the derivative of this fraction here. And guess what? I know how to do this. This is quotient rule, right? F is here, G is here, and so we'll go through this one together. That would make F prime, and just use the table, and we're going to want to remember these. Derivative of sine is cosine. G prime, the derivative of cosine is negative sine. Okay, and then we know our rule, right? Low d high minus high d low. Low is G, which is cosine x. D high would be F prime, cos x. Okay, minus high, that's sine. D low, okay, that's a negative sine, over low squared. So what's low? That's G, so that's cosine squared. Okay, let's simplify this. That's cos squared. Double negative is sine squared over cos squared. And you're looking at this like, oh, geez, it's going to be another crazy formula. But what's cos squared plus sine squared? That's just 1. So this is 1 over cos squared. And if we remember back to our trig, which is very helpful to remember, 1 over cosine is secant. The derivative of tangent is secant squared. Unboxing. Wow. So there you go. You can take what you know about sine and cosine, as these are given, and use our previous rules to construct some of the other trig functions. So, you can move this box, and I'll do it at the end of the video for the marked one, but I'll leave the box on. When you open this up in Word, you could just take the box and move it. Oh, don't look. But I think it's valuable just to kind of leave it boxed for now. And what I want you to just remember is, if you want to try to do the rest of these, which again, great practice for our rules. So if you want to do cosecant, you just have to remember cosecant, again, this is just our trig, is 1 over sine. Okay? Quotient rule again. F, G. Boom, do the quotient rule. Secant, 1 over cosine. Boom, do the quotient rule. Cotangent is 1 over tan, or is cosine over sine. Boom, quotient rule. Try these out. Go see if you can develop the derivatives for these functions only now knowing these. And of course, the quotient rule. So just a really nice thing to be able to practice. It practices a bunch of our rules, gets you working with these trig functions more. Really nice idea to be able to do. Okay, so once we have that, though, I'm going to move the box now. So if you want to try this, stop here and just go try it. We've got these as our list of derivatives. So what should we do now? We should just practice as many of them as we can. So that's what we're going to do. So let's go down here and let's just practice some examples. So, example. All right. How about f of x is 3x squared minus 2 cos x? Okay. So then f prime is going to be, so remember we have that subtraction rule which says I can do these separately. So this one's not bad, that's 6x, just using that rule for powers, x to a power. Okay, derivative of cosine, right? What's the derivative of cosine? So again, when you're first practicing these, you know what's a nice thing to do is just to do little scratch work here. I want to do the derivative of negative 2 cos x. Okay, that's negative 2 because we can pull the constant out, cos x. And then I just have to remember, oh yeah, that's negative sine, right? Negative 2, negative sine. You don't have to be doing these things all in your head, all in one go. You practice this enough, you will be, but it's not a necessity right now as you're learning. Bring this over, that's plus 2 sine x. Boom. There you go. Okay, let's try another one. How about let's let f of x equal sine x plus 1/2 cotangent x. Okay, so again, f prime, we've got a sine and we've got a cotangent. So you could do these separately. So just go back here, sine, cotangent, sine, cotangent. Sine is cosine, okay. Cotangent is negative cosecant squared. So let's go back down here. This is going to be a 1/2, because you can just take that out, negative cosecant squared plus derivative of sine is cosine. And then there you go. You can rewrite this if you want, bring the negative out. Boom. So it's just about practicing, right? Just practice these. And again, you're going to want to practice these in a bunch of different scenarios. You're going to want to put these product rules. You're going to want to put these in quotient rules. We are going to learn in not too long the chain rule. You're going to put those there. So let's do one of each of the product and quotient rule just to practice. Okay, so let's do another example. Let's let f of x equal, and then let's do one where we have to do the product rule. E to the theta tan theta minus theta. So then this should be f of theta. This is a very common variable to see here when you have trig functions. This is telling you that you're going to be dealing with angles. And in our class, we are almost always in radians. All right? You go to physics, maybe you're dealing with, or engineering, and maybe you're dealing with degrees, but we're going to be dealing in radians. So, okay. How do we do this? This is a product, so f g. Okay, so what do we need? We need f prime. Derivative of e to the theta is just e to the theta. Okay, and then g prime. Well, we gotta do this out. Derivative of tan is secant squared. The derivative of theta is just 1. Okay. So then let's put it together. So then remember, for the product rule, it doesn't really matter the order of these. Just what you have to remember is f and g will go together. No f and f, no g and g. And each of them should have one regular function, one prime. So for example, we've got f g prime plus g f prime. And again, these can go in a different order. We could do g prime f. Doesn't matter. So okay, let's just plug that in. That's e to the theta times secant squared theta minus 1 plus g was tan theta minus theta, and then f prime was e to the theta. And you could factor out an e to the theta if you want to, but you can just leave it like this too. Boom, all done. So just product rule. We just have to remember a couple more functions and their derivatives. All right, let's do one more. We'll do a quotient rule here. Let's do f of t is equal to cotangent of t over e to the t. So f on top, my high, g on bottom, that's my low. And then remember, we're low d high minus high d low. So f prime is negative cosecant squared x. G prime is e to the t. Okay, so low d high cosecant, whoopsie, did I say x here? Bad, bad, bad. Keep your variables straight. All right, cosecant squared t. Okay, so low d high minus high cotangent t d low e to the t over low squared. Remember, e to the t squared is e to the 2t. Just a little side note. Okay, so I mean, this is it. We could stop here. We could also try to simplify this a little bit, clean some stuff up, factor if possible. You can do that. You can factor here, but you're also okay just leaving this. The thing that you want to think about when you're asking yourself, should I be simplifying, is, are you going to use it for anything? Because if you're just done here, then okay, you just stop. But if you're going to be plugging in, maybe you want the slope of a tangent line, then you should simplify first, because it'll make your next steps easier. Simplifying first will make plugging numbers in much easier. It'll mean less plugging in, right? You'll be able to simplify, so you'll have less terms in here, which means less chance to mess it up, basically. So I'm okay with you stopping here, but if you're going to use this for anything, you should try simplifying first. And so, for example, you could factor out e to the t, which would cancel with one of these. So that would simplify pretty nice. But there you go. That's it. We've got our list. You've got to just get this in your brain, all right? And you might look at this and be like, oh, come on, I'll just look at the table each time. I'm telling you, you got to try to get this in your brain. You go to a physics class, engineering, you're going to be dealing with angles constantly, forces, and this and that. Okay, well, if you have angles, you have trig. So in both those classes, trig is everywhere. In the multiple classes you could take in physics or engineering, it's just everywhere. So you got to think like, okay, I'm going to do this physics problem that has a physics idea, and then I'm going to end up with a trig function, and then I need to use calculus on that to do derivatives. Do I really, during that whole process, want to have to try to take time to think through, oh, what's that derivative of that trig function? Or, oh, I got to go look that up? No way. You want that just right away, back of your head, it's in there, because you're already using your processing power on the physics idea, or in this class, on the calculus idea that we build on top of this. So that's where your processing power when you're doing those problems should be, not on, well, what's the derivative of tangent? You can't do that. You've got to get these in your head. It'll make your life so much better. It's possibly boring now, and that's okay. I think it is too. But sometimes you just got to do the monotonous, boring thing. Get it done so that it doesn't hurt you later when you're scrambling to find these derivatives. So just flashcards, whatever, practice a ton, get these in your head. And I do believe it will help to get these in your head if you try to go through the process of figuring out what the derivative of tan, cosecant, secant, and cotangent are by describing them like we did here, in terms of sine and cosine, and using the quotient rule. That's a great process for trying to like explore and think about and remember what these could be. So any questions on problems that you come up with, that you come across, let me know, as always, and I'll see you in the next video.